Alright, so problem number 16 is wanting you to find the slope of a line. First of all, Slope Dude would say this is what type of line? It's a nice negative. So it's going to be negative slope. That should eliminate, because it's going to be multiple choice, so that should eliminate some of your choices right there, knowing that this is negative slope. Now when we write slope, our top number should be how many up, it'd be positive, or how many down, and that would be negative. The bottom number is always how many to the right. So also remember that we need to start with the point that is closest to the left, so that this means we're going to be moving down 1, so that's a negative 1. And then we are going to be moving right 1, 2, 3, 4. So that is your answer for number 16, is a negative 1/4. Any questions about number 16? Again, I recommend writing down everything that I'm writing down. You have enough space on your paper to do that. I would not just write down negative 1/4 unless you are 100% certain how to find that. Alright, problem number 17 says, which of the following correctly describes the graph? Select all that apply. So we've talked before that whenever it says to select all that apply, it usually means, almost always means, that it's going to be more than one. So some people were asking me about what these words mean. First of all, let's talk about nonlinear and linear. Linear is a straight line. Nonlinear is the opposite, so not straight. So looking at this example in number 17, is this a straight line? Yes. So not straight would be like this. That is not a straight line. That would be nonlinear, okay? But this example is a straight line, so it is linear. Now the other two words on here are either a constant rate of change or a variable rate of change. What does constant mean? Just the word constant? It what? There's another definition that I'm thinking of here. Constant. No? Consistent. What does consistent mean? Same. In science class, you all talk about constants and variables when you're doing an experiment. Alright, constant means that it doesn't change. Okay? Constant means that it stays the same. For instance, the temperature outside varies. The temperature does not stay constant. It is not always 70 degrees all day long, every single day, is it? The temperature goes up, the temperature goes down. The temperature is variable. So if I was going to make a graph of the temperature, it would be nonlinear because it would vary, okay? So this is something that doesn't vary, it stays constant. So constant means it doesn't change. Variable means it does change. So that being said, linear, the word linear and the word constant go together, always. Okay? So your answer for this problem is going to be those two choices, A and D. B and C, the variable and the nonlinear, they would go together. So if I had an example of a nonlinear graph that was a variable, it's like example that I gave about like the temperature. It'd be something like this, okay? That would be nonlinear and variable. It changes. So linear and constant is a straight line and it doesn't change. This line decreases at the same rate, slope, okay? The same rate. Just keeps going down. Does that make sense? Alright, so linear and constant. Alright, problem number 18. Find the rate of change from the table. So rate of change is just another way of saying slope. Okay? The slope. So what we're going to do is we're going to find the change in y. That's going to be our numerator. And our denominator is going to be the change in x. And the reason for that is because we're finding slope, and it is rise over run. And rise is the vertical change, which is your y-axis, and run is horizontal change, which is your x-axis. Okay, so that's why I'm talking about that. How would you find a change in number? What operation would you use to find a change in number? Subtraction. Subtraction. So each time, look at the y values, that's your bottom. Each time, what's happening? They change by how much on the y's? It goes up 12. 24 to 36 is up 12. 36 to 48 is up 12. 48 to 60 is up 12. That's just finding a pattern, correct? When I look out to you guys, half of you are looking at me, the other half of you are completely not paying attention. There's no way that people didn't know that that was a pattern of 12. So the change in y is 12, so that's our numerator. And then our denominator is going to be our changes in the x. So again, looking for that pattern. What's the pattern in the x's? Plus 3. Plus 3. Plus 3. So our denominator is going to be a 3. Can you simplify 12 over 3? Yes. What would 12 over 3 be simplified? 1/4? What can I divide both 12 and 3 by? 3. So what's 12 divided by 3? 4. And what's 3 divided by 3? So 4 over 1 can be written as 4. That is the answer. Then let's look at number 19 now. So in number 19, it says graph the line when given the slope and 1 point on the line. What do you put on there first, the slope or the point? The point. So first, graph the point. -2, 4. That's our first step. So over on my graph, I'm going to -2 on the x-axis and up 4. -2, 4. So make sure, look at your study guide. Did you put a point at -2, 4? So the second step then is going to be using your slope, which is -1/3. What directions does that tell you, a -1/3? Talia? Alright, so because it's negative, we're going down 1, and then we're going to go right 3. And that is where our second point is going. So down 1 and right 3. So our second point should be at 1, 3. Again, that puts us at 1, 3, for anyone that can't see that. So we graphed -2, 4. Then we used our slope, down 1, right 3. We put our second point. And then we should connect those 2 points. Number 20, explain how you graphed this line. So basically, it's like what you would say to someone that just walked in here and you had to tell them how to do the problem. First, I graphed -2, 4. Then I went down 1 and right 3 for the slope. Perfect. Okay, so you're saying those words and you're writing that. So when you do this on the CQA, you'll be typing that in. First, I graphed -2, 4. Then I used my slope, down 1, right 3. Okay? Questions about number 20 or 19? All right, looking at number 21 then. I think number 21 is one of the more challenging questions. We've talked about proportional relationships. Proportional relationships. And we said this is the requirements of a proportional relationship. First of all, it has to go through the origin. And secondly, it needs to be either positive or negative slope. It cannot be undefined or 0. So undefined, as a reminder, is straight up and down. 0 is straight across. So for some people that have a hard time visualizing, the easiest thing for them will be to get a piece of my graph paper, which I'll have sitting up here, and actually graph the 2 points. And see, does it go through the origin? What point is the origin, by the way? 0, 0. Does it go through the origin? And would it make a positive or negative slope? So not any straight lines up and down, not any straight lines across left to right. Okay? So if you notice in A, what do you see? 0, 0. So A would be one of our choices. And again, this is another select all. So it's going to be more than just the A. If we think about 1, 0, and if we were to graph, and again, you can use graph paper on the CQA. If we were to graph 1, 0, that would be here. Would it be possible for there also to be a point at the origin then, if it's a straight line? No, because it would go like straight across, and we don't want that. So B would be impossible. So then I think about C. What do I notice that's similar about C? What do you notice about C? Anything? They both have a 4 as the X value. So if you were going to graph 4, 6, you'd go over 4, 1, 2, 3, 4. You'd go up 6, 1, 2, 3, 4, 5, 6. And you'd put a point. And then you'd put on 4, 7. Right, 4, up 7. That's going to make a straight line, an undefined line. We don't want an undefined line. So C would not work. And again, some people can visualize that. Other people will need to graph it, and I have graph paper for you. So then our last one is D. D says 2, 2. So right 2, up 2. And it says 3, 3. Right 3, up 3. That would make positive slope. And that would also go through the origin, because it'd be 1, 1. It'd be 0, 0. It'd be 4, 4. Okay, so that's going to make that straight line. So A and D. Again, I think that is the toughest one because it doesn't say to graph it, but that's going to be the easiest thing for you to do. Okay? Yes. All right, let's look at question number 22. So in question number 22, it says the table shows a proportional relationship between the number of hours Skip works and the amount of money he makes in dollars. How much money does Skip make in 1 hour? If he's making $16 in 2 hours, how much would he make in 1 hour? Very good, $8. So this is basically finding a unit rate. Okay? So again, that's just finding the unit rate. So I don't think that one's that bad at all, right? Any questions about it? 23, identify the constant of proportionality in the equation. That's just another way of saying slope. When we're looking at equations, I'm going to write this equation bigger. Where is that slope located, that constant of proportionality? Where is it located? It is always located between the equal sign and the x. Always, always, always. So there is no math involved in this problem. All you're doing is looking at the equation and looking in between the equal sign and the x. And there's your answer. Okay? This is probably the easiest question on the test if you're listening to me, that you're looking between the equal sign and the x. Question 24, you have to fill in the missing parts of the table. You have the top row, which is money. You have the bottom row, which is fabric in yards. So again, I'm kind of looking for patterns. I think the top row, it's missing a lot more numbers. It's going to be harder to do. So I'm going to do the bottom row first. 2, 3, 4, 5, 6, 7. Now, before I figure out the top row, I'm going to go ahead and figure out if I know that 3 yards equals $7.50, let's go ahead and figure out how much 1 yard would be. And how would I do that? Do $7.50 divided by 3. And for those of you with calculators, what is that? 2.5. So if we're talking about money, that's $2.50. So $2.50 for 1 yard. Do we need $2.50 in our table? No, because there's not a 1. It starts with 2. So 2 would be 2 times $2.50, which equals $5. 4 yards would be 4 times $2.50, which would be $10. 5 would be 5 times $2.50, $12.50, and the last one would be 7 times $2.50, $17.50. And now our table is completed. We also could have, once we saw the pattern that this is going up $2.50 each time on the top column, or top row rather, we could have just added $2.50 plus $2.50 plus $2.50 plus $2.50 plus $2.50. So that's kind of just a personal preference on which way you prefer to do it. Okay? But we had to find this, once again, this is a unit rate. We had to find out how much per 1 yard to figure out the rest of the graph. Okay, the table. All right, question number 25. Using the table of values from the previous question, what is the value of the constant of proportionality? This is just asking you, again, that unit rate, that it's $2.50 for what? 1 yard. $2.50 for 1 yard. That's all it's wanting to know. So it's something that you already had to find in order to complete the table. All right, question 26. It says, the graph represents a proportional relationship between time in minutes and the distance in feet a sloth travels. So some of you have seen a sloth and some of you haven't, but they move pretty slow, okay? So it says, write an equation that relates the number of feet, F, to the number of minutes, M, that the sloth is moving. All right, so again, feet is F, minutes, time is M. We have to use the variables given to us. Do not use your own variables. Use the variables that are given to you. All right, so let's look at what this graph means. And you have it in front of you. I know it's kind of small up here. For every 1 minute, how far does it move? In 1 minute, it moves 3 feet. In 1 minute, it moves 3 feet. How many would it move in 2 minutes? 6. How'd you get that? 3 times 2. 2 times 3. So you're taking the amount of minutes times 3 to equal the feet that it travels. Again, you're taking the amount of minutes times 3 to equal the feet that it travels. 1 minute times 3 is 3 feet. 2 minutes times 3 is 6 feet. 3 minutes times 3 is 9 feet. Okay? Part B says if it moved 7 minutes, so same thinking, 7 minutes times 3 would give you 21 feet. So what I've seen some people do is they mess up what they're multiplying by. So just make sure it makes sense what you're saying, okay? And again, use the variables that are given for this. Now, in the very last problem, which was on its own separate piece of paper, it wants you to define the variables, so you're choosing the 2 letters, and then write an equation, and then answer a question, all right? So let's do that last part. So it gives you a graph talks about the bags of dog food and the pounds per bag. They must be pretty small bags, right? So we need to find two variables, and it can be any two variables that you want to use. All right, P for pounds. So P equals pounds. All right, F equals bags of dog food. So you're saying what's on the axis, okay? Bags of dog food. So it doesn't matter. You could choose X and Y. You could choose M and O. It doesn't matter which two letters you choose as long as you're saying what they represent. I would make things, choose letters that kind of go along with things. Like I chose P and B when I did my answer key. But P and F is fine, okay? All right, so the next thing that we're going to do, and this is question 28, is we are going to write an equation for this. So again, we said this was P, and we're saying this is F. So let's look at this. In one bag of dog food, one bag, and again, that's F, there are how many pounds? 3 pounds. Whoops, I'm going to put a P up here. In one bag, there are 3 pounds. So we need to write an equation for that. So in 2 bags, there would be 6 pounds. In 3 bags, there would be... So we're taking the bags... I'm going to write this out first before I use variables. We're taking the bags times 3 to equal the number of pounds. Okay? So again, for bags of dog food, you all chose F. So F times 3. And for pounds, we chose P. So there would be your equation. F times P, or F times 3 equals P. So your last question then, number 30, for 9 bags of dog food, how much would that weigh? 27 pounds. Okay, I am